Back everybody, this is our second session of the day is on green technology adoption in commercial and industry. I guess we could have also called it the hard to decarbonise sectors. So these sectors are of course extremely important for the fight against global climate change. I think they're also important for development finance institutions because as we look forward over the coming decade, as the renewable energy sector becomes more mature, it is going to be these industries where there is a need for investors who are willing to pioneer things, who are willing to take risks, and this is going to involve taking technology risk. It's going to involve even sometimes taking demand risk in a way that you don't have to do when you're doing generation with an offtake agreement. So there's an awful lot here for DFIs to get their teeth stuck into. This is a huge topic, and we have a panel that represents some of the most important elements of it. We have green hydrogen, the garment industry, and steel. I'm sorry to say that you might have been expecting Professor Lindsay Whitfield to speak on the garment topic, but she has had to withdraw at the last minute, unfortunately. But we've got a great panel nonetheless. Again, I'm going to ask everybody to start with introductory remarks. Again, we're going to have some slides and some not, and then we'll have follow-up questions and Q&A. So those of you online, please be listening and thinking of what questions you might like to ask the panel as we go. And again, I'm going to ask the speakers to introduce themselves. Stephanie, could you get the ball rolling for us, please?
Of course. Hello, everyone. So I'm obviously also going for overkill. I have slides and notes. So hi, I'm Stephanie Hirmer. I'm Associate Professor at the University of Oxford, where I lead a team that looks at place-based decision-making of infrastructure. So we commonly look at how infrastructure can support both development objectives in a country and align with localized needs in a country, but also be economically viable. So today I will focus on green hydrogen, but my portfolio is rather large. I also look at AI. I look at critical minerals, mainly all on the African continent. I also lead a program in Ukraine where we look at the integration of green hydrogen into sort of the long-term decarbonisation goal of the post-war reconstruction, but also considering the immediate energy security of the country. So I thought, for the benefit of everyone, because not everyone works in the field of green hydrogen, I'm going to give a bit of a lowdown of where the world is at in terms of green hydrogen. So in 2022 was, I think, was COP27. In any case, COP27 in Sharm el-Sheikh was the hype of the green hydrogen agenda, I would say. I ended up in approximately 12 to 15 different sessions on green hydrogen and the importance of it on decarbonisation, all of which focused on export from Africa to the West in order to decarbonise our sectors and to afford our lifestyle. And sort of this got me interested in working in green hydrogen at the end of the day, because again, my research really looks at equity, governance and risk to do with infrastructure. I'm in the engineering department. I also should put a disclaimer there in case people start asking me investment questions. So that was really interesting to observe, and during that time, a lot of agreements got signed between Germany and Egypt, between the European Union and Namibia. There were also some really ginormous project signs with Mauritania, where the cost of the green hydrogen project exceeds 4 times their GDP. So the world moved on. To date, we have approximately 200 investment, projects that had investment committed, and that was probably before the report came out on Wednesday as I was preparing for this. So on Wednesday, the Financial Times, as you can see, put out this graph basically informing the world that approximately 60 major green hydrogen projects have been cancelled. And these include projects from BP, Exxon, and all sort of major investors, with a lot of capital, I would say. And we hoped that they would probably become greener over time. So This equates to approximately 4.9 million tons of annual output and is 4 times the world's current installed clean hydrogen capacity, according to the authors. So for us that work on modeling of economics of green hydrogen, this is not a surprise. I think that the world jumped on a hype that could not be fulfilled. The cost assumption of it, the world believed hydrogen could be produced was always extremely optimistic. We had the first green hydrogen auction, which with a bid as low as 2.8 kilograms of green hydrogen, 2.8 euros per kilogram of green hydrogen. Many of them are now obviously withdrawn. So I think over the years we've seen that these bids never came through. My study, so what I work on, and I hope I get this right, yeah. So I look at the levelized cost of green hydrogen, and we've done this study across the African continent where we basically looked at 10,400 different points, all potential locations for green hydrogen, and looked at different cost of capital, at different scenarios of de-risking and cost of capital. To make it possible, some are with a very optimistic interest rate, those and others with a more moderate one representing current interest rate level, but then obviously also de-risking scenarios, i.e. offtake agreement from the European Union, for example. During this project, we found that the lowest we can achieve is 4.2 to 4.6 kilogram euros per kilogram of green hydrogen produced. So it's significantly higher than what these auctions had put out, right? There's some structural pressures and barriers that have also led to the reduction of these like people withdrawing, and so demand has not materialized. Costs remain much higher than production from blue hydrogen. Infrastructure is lagging, such as pipeline storage, transporting it to Europe, we're simply nowhere near. And policy is very uncertain, particularly when we look at places such as Africa, right? I would, however, say that this is not a failure and that we shouldn't be giving up on green hydrogen. I'm very technology agnostic, but it is a technology that has a role to play in certain sectors. And I think one of the factors that contributed to us was this hype of giving these very unrealistic numbers that us as academics always have postulated to be wrong. And there is some sectors which have a comparative advantage. And so I think, for example, it has a role to play in green metals, such as steel. So I'm excited that someone will be talking about green steel. Fantastic, where it can cut emissions by 90%. It has a role to play potentially in cement. It's a little bit more complicated, as you can only decarbonize about 40% of the process. The rest would come from CSC and other technologies. And one of my PhD students is looking at that in the case of Nigeria, where we're, for example, looking at the potential and also the comparison of the different technologies on what's the option to decarbonize cement, essentially. Then there's obviously chemicals and fertilizers. So I'm also very excited we have someone talk about green fertilizers in a moment. And then obviously there's aviation and shipping. But how much green hydrogen is actually needed for us to achieve that? And again, the world is very uncertain at the moment, but we know that 95 million tons of green hydrogen annually are needed to replace the current grey and black hydrogen demand. So this is that alone. The IEA had estimated in 2022 that at least 12 million tonnes of export by 2030 would occur. This has now been reduced in the most recent report that came out a few months ago to 0.8 million certain and another 1 million with strong potential. And this has got also to do with the major drop of around 75% in projects delaying or lacking buying. However, needless to say, I think there is a role, right? Like I want to emphasize this role in certain sectors. What I think is also interesting is where does this green hydrogen come from and where will it be most cost competitive? So as part of our study, we also mapped every single green hydrogen project that has been signed and in various stages of the development process. So in Africa, we mapped 34 projects. And they have been announced or committed, and as I had already mentioned, some of them are multi-million projects. I mean, they're absolutely gigantic and ginormous. However, these multi-million-dollar projects require land, water, renewable generation, transmission, and ports. And this is really where my interest of my research comes in. So how do you not only focus on this export dimension, but how can you also have benefit for the countries in which these projects are being implemented in? Obviously, all of these projects are extremely ambitious. They are underpinned by high cost of capital. It's 2 to 3 times more that of OECD levels. There's uncertainty of off-takers, which also the recent developments have shown. There are very weak government frameworks. And then, of course, there's energy poverty in these countries where you then basically face, should the lowest cost of renewable energy, which makes up the majority of the price of green hydrogen, be utilized for green hydrogen production and export, or should it be utilized to provide power to the people in very power-poor nations? So my team, together with that of TU Munich and others, we basically look at some sort of interconnected questions. So firstly, where should green hydrogen be cited to be most cost optimal? So that was the graph you saw earlier. What social and environmental constraints could block real-world implementation? So we're also mapping social and environmental impact, overlaying it to the opportunity of costs to actually identify, well, where does it actually make most sense? Which domestic sectors should be prioritized so hydrogen delivers shared value and not just export revenue? So, for example, obviously, fertilizer production is very important in Africa. Also, steel, cement could play a very important role. And what financial and technical mechanisms could meaningfully reduce levelized costs. And I think that one is extremely important because at the moment, all we're doing is we're taking account of land, water costs, batteries, renewable energies, but we're not really saying, well, we're not optimizing how power is being used in the countries that could further reduce the cost of green hydrogen. So this is something we're also working on. I'm going to leave it here.
Thank you very much. And Kinar, over to you.
Thank you. Bit of a brutal introduction to the green hydrogen space when you have a company that's trying to make it work. So, but no, I'm Kinar Kent. I'm the CEO of Westgass. We're a niche Norwegian energy company. Started in 2016 in natural gas distribution and marketing. Built a 10 terawatt-hour portfolio. Sold it so we could focus on project development, energy-intensive project development. With a strong, everything that we do is targeting structural inefficiencies in supply chains. So why green hydrogen and why are we looking at fertilizers? We have a project that we're co-developing with IPS. IPS are a very well-established investor, operator of industrial scale assets across Central Asia and Sub-Saharan Africa. They work together with BII on quite a few projects. Why did we look at green fertilizers and Uganda in particular, which is where our first project is? It was, in effect, to answer what Stephanie just mentioned, where are you using that power and who are you using it for? I'll talk first a little bit about Uganda and one of the structural issues that they have when it comes to agriculture, and then I'll come back to the hard-to-abate question. Uganda is sort of an 80% agrarian society. They have a population that's doubling in the next 20 to 30 years. And they suffer from some of the lowest agricultural yields in the world. I'm not the mathematician, but when you see low fertilizer use, poor agricultural practices, a huge amount of deforestation, you can put the numbers together and you have an answer as to why they have this problem. They also have a lot of renewable power. They've built a huge amount of hydropower capacity, and a lot of that is unused because the grid is too expensive to build out for now, and they're struggling to pay the debt to monetize that power. So you have a structural issue in the supply chain or value chain. And when it comes to fertilizer use, I mean, a lot of people don't like fertilizers, and I think rightly so, because they are produced from predominantly natural gas. 1 ton of fertilizer equates to approximately 1 ton of CO2. You've got huge shipping distances. You've got supply chain challenges through crossing borders, trucking, theft, adulteration, whatever you. So there's very concentrated population in Russia, Middle East, Europe, produce all this fertilizer, send it across the world, get farmers to pay 2 to 3 times the price for a bag of fertilizer as they do over in Europe, and then import all the produce from it. It's not a very fair system. So why not produce this locally? And that was the question that we asked. You have the power. Fertilizers, nitrogen-based fertilizers were born from water electrolysis, which is what you use to make green hydrogen. Back in Italy and in Norway, that's how Yara started. They used exactly this technology over 100 years ago, started producing nitrogen-based fertilizers, and we saw agricultural yields just explode in the developing world. And now you see that in Brazil and in India. So why don't we go back in time, use this proven technology, implement it in a country that has the power and has a real need for increasing fertilizer use. So it makes commercial sense, it makes economic sense, and from an impact perspective, the green is just the bonus. That 200,000 tonne a year of CO2 saving from our plant is just the bonus. The real impact is you're helping farmers generate more food, not just for eating, but for export. Coffee yields can go up. And what you see is about $100 million spent on fertilizers a year will generate about $500 million to $1 billion a year in increased yields. So society will really benefit. The challenge we face is we don't monetize that. That is public good. And so when it comes to developing these projects, you have a huge challenge in market price risk. It's not a matter of finance. There are plenty of people that want to finance projects like this, not just DFIs, but private institutions. The technology exists. There are wonderful engineering firms out there who will build you whatever you want if you give them enough money and enough time. And we don't even need to do that because they've done this before. The land is there, we've secured it. We know that you have to go through the environmental studies. So all the general project risks can be taken care of. The power is there and there is suppressed demand. But with every renewable power or with every renewable project, what are you doing? You're competing with fossil fuels. And fossil fuels are not sold on long-term fixed price contracts. They just simply are not. So the only way that works with solar, or it had worked with solar, or it had worked with wind, was you started with government concessions. You had fixed price contracts that were underwritten by sovereign guarantees, and then you started having things like contracts for differences and other market mechanisms that would come later. If we want to look at hard-to-abate industries, and you're going to manufacturing companies or other sectors, and you're saying, hey, switch out fossil, start doing green, but as a finance institution, we want you to make sure you have long-term fixed price contracts, you have a problem. So my proposition to this panel today is this isn't a technology issue. This isn't a desire to invest. This isn't an entrepreneurial issue. This is a finance issue. If we talk about being innovative with technology, my challenge to DFIs is be innovative with your finance solutions. Make your finance fit the problem. Don't make the problem fit the finance. Mandates today are built around OECD utility type projects. You look at the Atome project, which I think is fantastic for green hydrogen. For those of you who don't know it, there's this project in Paraguay. It's being developed by a company called Atome. They're far ahead of where we are, and I really respect them for what they've been able to do. They are implementing this. They've got a lot of support for this project. Exactly the same concept. Use green hydrogen to make fertilizers so it can be used in the region. But you scratch away a few surfaces. British PLC investing in Paraguay, taking Paraguay molecules to produce fertilizers, being bought by Norwegian Yara, who is only doing this because they can sell it into Brazil. So what's happening to Paraguay? The question that Stephanie asked. How is that power being used for local market? And when we look at the model that we're trying to develop, it's local fertilizers for local farmers. How can Ugandan farmers benefit from this? And how can they be shielded from that price risk? When fertilizer prices are high, it means gas prices are high. We don't want farmers to face that. When fertilizer prices are low, gas prices are low, but that means we have a challenge because we have to be able to compete. So instead of talking about concessional finance, instead of talking about grants, instead of talking about subsidies, in order to abate these industries, can we start talking about insurance mechanisms? How do you protect investors to recoup that investment over time and allow the market to develop so market mechanisms can work as they do today in the Western world?
All right, thank you very much.
Thank you.
There's loads of questions I'd like to ask, but I must resist. Zahid, we were going to come to you next to talk about the garment industry.
Sure. Thank you. So I'm Mohammed Zahidullah, Chief Sustainability Officer at Ebel Group. I've been working here for the last 23 years in this organization. And this company was formed in 1991. It's a family business of 4 brothers. And they started in 91. They started as an SME. So with 100 people and about 30 machines, they started from their own residence. And this is one of the very good example of how a SME can grow into a big corporation. Today we have 51,000 employees. We have a revenue of about $1 billion. Our garments and textile business remains the core. 90% of the revenue comes from here. And we have also diversified into telecom, into ceramic tiles, into pharmaceuticals, into dredging, and also into now promoting semiconductor market for Bangladesh. So this is the journey from SME to large corporations. And besides, since our core business is into garments and textile, the scenario is that, this is very, in terms when you talk about textile, it's very energy and water intensive. And at the same time, the consumer demands are very high. New legislations have already come in and coming in also more and more from Europe and other countries like the European Union due diligence, then, the digital passport and other things and all. So here we are required to maintain a very high standard in terms of social and environmental compliance. And also the target now is that, how we reduce our water consumption and also the GHG emissions. So on a baseline of 2019 to 2020, we are supposed to reduce and bring down to 56% by 2030. And same thing goes with the water also. And for us as an organization, this has become a very tough challenge. Reason for it is because, we started these interventions way back in 2010-11 through one of the project of IFC, which is known as Cleaner Production, and then followed by a partnership for Cleaner Textiles, through which we did get huge benefit in terms of bringing technology in interventions, reducing greenhouse gas emissions, and also in water. So now, we have come to a point where it's not possible for us so much to reduce, but at the same time, our brands and buyers like H&M, Puma, George and others and all, they do demand these things for us to do the interventions and all. So the toughest thing is that, cost of doing business is going up, whereas the price of the products are going down. We all are buying products, these things, and we know that it's not increasing, it's going day by day down. The fast fashion is creating a lot of problem for us also, So here the consumer demands are very high in terms of sustainability. We have the Gen Z who are very, very educated in terms of sustainability practices, in terms of social. They want to see the social and environmental impacts and footprints and all. So there is a lot of pressure on the brands which comes to us. But at the same time, the brands or the buyers, they do not pay for it. Their thing is always the economy is down, recession is going on, you need to cut down on the prices. But at the same time, there's a high demand on the social and the environmental impact. So we are in a big dilemma and we still need to survive. In this business, our heads are just above the water, we are just breathing. It's not that, it's a thing. But again, we see opportunities. We see opportunities only because, if there's a collective effort in terms of reducing these emissions and also the water consumption, then it's possible. So for us as an organization, we are almost per day, we have a very big capacity. We are vertically integrated, right from the just input cotton and all the way we move. In fact, in one of the spinning mill, BII has invested 2 years back. And so what we are doing is that, for us, what we see is that, buyers do not want to pay the price, but these interventions are cost of the product. So here what we see that, as an organization, we are manufacturing 500,000 pieces of garments per day. So 500,000 pieces of garments into 26 days, into 12 months, it's almost about 156 million annually what we are doing. Now, if the consumers who are buying, if they pay 10 cents on each piece of garments, then annually we can get $15 million. And we feel this is good enough for us to go for the solutions. So this is where the gap is, how those consumers can pay in. We do see solutions in terms of it, because today the world is digitally connected, organizations and workers are all connected. And we feel that, the way the tax is collected in terms of sales tax from the products by the government, These money should be collected also in terms of tax with regard to the environmental implication or GHG or whatever we say that. And this money should come back to the factories individually so that they can do these implementations. And it's not about one factory, it's across the supply chain, across the world. So it's all about how we can come in. We spoke to we have frequent visits from ambassadors of UAE to our factory. And one of the ambassadors, when we spoke to him about this thing, he said, we know this is a very good solution and it's doable, but it will not happen because all the 27 states are not aligned with it and it's not going to happen. So this is all about it. Thank you.
Thank you. I want to turn to you next, Munish, to tell us about the African steel business.
Thank you, Paddy, and thanks to BI to invite me here. My name is Munish Modi. I am Group CFO and CEO for Aluminium and Steel Business for African Industries Group in Nigeria. I am working with the group same like Zahid, 23 years. By profession, I am Chartered Accountant. Then I did my MBA from London Business School and Global CXO course from Wharton. AIG is a major industrial group in Nigeria. We are into steel manufacturing, steel processing, aluminium manufacturing, lead recycling, power generation, agro processing, chemical manufacturing, glass manufacturing, wood processing, etc. We started manufacturing in 2004 and now we have almost 25 manufacturing plants across Nigeria. We employ more than 10,000 employees. We are biggest manufacturer of steel, aluminium and lead in Nigeria. We are also having businesses in Romania where we do agriculture farming. We have got almost 30,000 hectare agriculture farm there. We also went into the power business back in 2012 and today our capacity is almost 140 megawatt. So we started with gas to power and now we are moving to solar power. Our current capacity on solar power is almost 40 megawatt and now we are putting another plant to produce 200 megawatt. So idea is to just move away from gas to power and go more and more into solar power. Then this is the plant where we are talking to BIF for financing and there are a few other DFIs we are talking to. Presentation. So decarbonization of metal and steel industry in Africa. Okay, before going to that, I am going to give some facts about the current reality. Africa is the least contributor to CO2 emission. So current contribution to CO2 emission of Africa is only 3%, whereas if you look at Asia, it is 50%. If you look at North America, it is 14%. And if you look at Europe and Russia, it is almost, sorry, I can't see it. Let me just open it. So Russia and Europe is having almost 10% contribution. So if you look at it, the Africa is the least polluter as far as the CO2 contribution, CO2 emission is concerned. On country level emissions, China contributes almost 34%. USA contributes almost 12%. India contributes to 7.5%, and Nigeria contributes to 0.3%. So if you compare China with Nigeria, Nigeria contributes only 1% of what China contributes. If you look at USA to Nigeria, Nigeria contributes almost 2.5% of what USA contributes. Per capita CO2 emission side, Qatar generates almost 35 tons per annum, whereas Kuwait 25, UAE 20, USA 14.2, South Korea 12.2, and Nigeria 0.55. So Nigeria is not the huge emitter of the CO2 emission. Whether this low CO2 emission is help to the country or it goes against the country. On positive side, yes, it doesn't impact environment that much. So Nigeria is not impacting environment that much. But on the negative side, limited industrialization is there. The industrial development started very late in the country and there is acute power shortage. Nigeria has got almost 40% of the power available than what they require. And it is when there is very low level of industrialization. Okay, so Nigeria metal industry journey. The industrialization in Nigeria started back in 2000. Before that, there was very minimum industrialization in the country. AIG was the catalyst. We started in 2004, manufacturing is still in the country, and we started with 100,000 metric tons. Our current capacity is almost 1 million metric ton. And then industry started to emerge, and today the total capacity in the country on steel manufacturing side is 2.4 million ton. On aluminum manufacturing side, it is 200,000 metric tons, and on the lead side, it is almost 100,000 metric tons. Environment impact. Nigeria produces the steel from scrap, which is much less pollutive. And also, Nigeria is producing the steel, aluminum, and lead from the induction furnace technology, which is far less pollutive than the electric arc furnace technology and the gas and power coal-based arc furnace technology. So Nigeria is producing steel from scrap is putting much less CO2 into the environment. If you look at energy consumption side, when you produce from scrap, energy consumption is almost 50 to 60% lower. When you produce from scrap, CO2 emission is almost 50 to 58% lower, and the water and air pollution is almost 70-80% lower. Key metrics. Before the start of steel production, Nigeria used to export all of it is still scrap, and now 70 to 80% of the importation of steel and other metals have come down in the country. So the industrial development is definitely helping the country. Now let's talk about key challenges, what we are facing in Africa. So if you look at lack of capital, Africa has manpower, but they lack skill. Africa has resources, natural resources, but they lack capital. So Africa needs almost $2.8 billion by 2030 by the estimation of AFDB to meet the climate goals. There is a technical skill sets gap. Then there is a very low industrial base. Only 3% of total global output is coming from Africa. 1% of steel production is coming from Africa, and 2% of global aluminum production is coming from Africa. Different regional realities, we can't use the same yardstick what we use in the developed part of the world when we talk about Africa. There, the income levels are very low, affordability is very low, industrial development is very low, and also the CO2 emission contribution is far lower than any other part of the world. The green energy technologies are very expensive. I'm not sure how much Africa can afford. The unemployment rates are very high. It's on an average 30 to 40% unemployment is there. And in some part of Africa, it is more than 50%. Poverty rate is very high in the country. I think in Nigeria itself, 70% people are living below the poverty level. Africa average per capita income is almost $2,000, whereas world average is $12,000. And if you look at developed countries, it is in the range of $45,000 to $50,000. So if you compare with the developed countries, Nigeria has got almost 2.5% per capita income. Then we look at the power availability in Nigeria. Nigeria only has got 40% of power available. 600 plus million plus households lack stable power supply. Diesel generators fill the gap, which the cost is very high, and CO2 emission is very high. If there is a policy and regulatory uncertainty, I think we should definitely talk about that, which also affect the business in Africa. Ways to overcome obstacles. Support from developed nations is essential, especially looking at low emissions in Africa. See, that's where the role of DFIs and other international financial institutions come in. But most of this financing is coming as debt. Whether Africa can afford that debt or not, like we will talk about the other projects, but the GDP levels are very low. and there is a certain extent Africa can go when it comes to the debt financing. And beyond that, it would be very risky for Africa. So instead of debt financing, I think they are looking more of the equity financing so that risk can be shared. Then build robot support system for the green initiatives. There is a real need to build a robot support if we really want to develop the green energy in Africa. This means offering financing incentives, green credits, and essential risk-taking instruments. Promote local manufacturing. In Africa, the manufacturing is still pretty low. We are exporting raw materials from Africa, and that is going to the other countries, and how they are using it, we have no control on that. So if really we are serious about the environment thing, in that, I think there should be, Africa should be promoting, or the international community should be promoting the manufacturing in Africa. Empowering local economies is long-term solution for these problems. Better collaboration between Africa and rest of the world, building bridges between developed and developing nations through innovative partnerships, shared responsibilities, and a powerful combination of technology, finance, and local capabilities, building, collaborate a better future. I think that is something very important. And then then practical environment compliances. There are a lot of restrictions are being put on using the local resources in Africa. I think world used resources before Africa started to use. And when Africa started to use those resources, the restrictions started to come. I think that should be considered when financing the project in Africa. In 2000, we started our power generation in 2012. And at that time, we got financing from DFI. After 2017, the DFI stopped financing gas to power. We need to understand that Nigerian gas is an associated gas which comes with the oil. Nigeria either use that gas or flare into environment. Is it not better to commercially use the gas instead of flaring it into the environment? It is it's more environment friendly if we use that gas for the commercial purpose instead of flaring into the environment. So we should categorize, or we should not categorize the associated gas with the non-associated gas, like shale gas or gas which is coming with the coal. Now, unlock green certificate potential. There is no market which recognizes Africa green initiatives. So we need to have a market where Africans can also trade the green certificates.
Thank you, Munish. I'd like to come back to you later on some of the points I know you're going to get to, particularly around the hydrogen thing. But I would like to move on to Ralf.
Thank you very much. Thanks for having me. Can you hear me? Fantastic. I'm Ralf Martin. I'm a professor at Imperial College, but I'm also currently with the research department of the IFC. They have a new research department, very much interested in private sector. And I thought I have maybe more a macro perspective, but I'm basing this on a recent report we did at the IFC, which you see there blended in. And I think the question there was, we all have a strong interest, since we're humans, that new technologies are adopted that mitigate carbon. But increasingly, this becomes also a business, right? And we have seen many people here already who are associated with various innovations and businesses that are providing, in some shape or form, services that help us to adapt or mitigate emissions. And the question was, to what extent do we see innovation happening there in developing countries as well, and to what extent can this be part of a story to not only decarbonize things, but also to develop and grow economic activity in developing countries? So increasingly, last week I was in Vietnam, and they're very much, and many other countries like that, they want to move from a sort of a model where we just invest in infrastructure into a model where we are innovation led, yeah. And then the question is, what are these technologies where developing country innovators are maybe more successful than other areas, and are all technologies the same, or is there maybe something in particular about green technologies? And of course, we have to be realistic in that. Overall, most innovation still happens in developed countries or in high-income countries, in places like London or Silicon Valley and Tokyo. But I mean, there is an increasing amount of innovation happening. You know, you see the figure there on the right, about 20% of innovation is happening now in emerging economies. Of course, a lot of that is now China, but there is activity in other places. And sort of an interesting finding which we found there, very early on, is that yes, there's more happening in all of these places you know about, but if you look in proportion, right, the share of innovation that is happening in low and middle income countries, a much larger fraction of the innovation there is in broadly defined green technologies. And we take a very sort of liberal view on what green is. So that includes mitigation, but it also includes adaptation technology. And what you see there, we rely on the work by the European Patent Office and others to sort of, use their expertise of all the examiners, what is actually a green technology. So you see that in all emerging and developing countries combined, the share of green innovations in total innovation is sort of around 8%, around 12%, 13%, whereas in high-income countries, it's only 8%. Yeah? So, and I think this indicates is a certain, maybe you might call it a revealed technological advantage for green technologies broadly defined. In the report, we have a discussion about why this is the case. We show some evidence that basically, as a group, green innovation as a whole is kind of simpler. So there are less barriers to enter it, right? You don't, for some green technologies, right, if you talk about solid-state batteries or something like that, you need, and on maybe also a lot of the hard-to-abate stuff, right? We come to that in a second. You might need a lot of capital to just do the research. You might need a big laboratory or a very sophisticated laboratory. You need sophisticated training of engineers and scientists. But as a group, as a whole, on average, green technologies seem to be a bit simpler and cheaper per innovation step, which makes them more accessible to lower income countries, we argue. And we show some evidence for that. Yeah, and that would be more sort of an innovation push argument, right? So it's something about the green technology, the supply side of the green technology. But we also see that a lot of this is driven by adaptation innovations. And I think this is to some extent a sort of demand pull where we see that, what we talked about this morning, farmers and developing countries have this sort of need to adapt to the new situation. They need new seeds. They need new ways of doing agriculture. They need new ways of construction. And so that creates a certain pull where innovators in these in the countries then are more inclined to focus on that than there might be in London. You might say, okay, fine, these are just numbers, quantities, but is it really a quality innovation? Should we really hope that from this can come some kind of sensible and profitable business? And so what we're doing there, we're trying to understand the quality primarily by looking at the knowledge spillovers and valuing the knowledge spillovers that emerge from various types of innovations. And again, on average, we find there that whereas a developing country innovation on average is slightly less valuable in that sense than compared to high-income countries. Actually, when it comes to the green category, again, we find that on average, actually, the quality there is higher, maybe even higher than in high-income countries. And we push that a bit further into trying to understand now, okay, where do we maybe have the highest returns to further investment in R&D? And again, we find that, while there are a lot of other, technology fields broadly defined, for instance, you see it here compared to AI, where we find higher returns than in green as a whole. Green definitely in developing countries provides more than average returns, compared to any other technology you might be investing in terms of R&D. We have also an emerging, it's still a bit of a prototype, Explorer, where you can sort of tailor these kind of results however you want to look at them. You see the QR code there. So now the question is, okay, this is green overall, but I mean, a key insight of the report is there's a lot of variation, right? This is not true in all countries. It's not true for all technologies. And you really need to look into a case-by-case basis. This was, in a way, the motivation for doing an Explorer where you can really drill down in various ways. So what about, hard-to-abate sectors broadly defined. And yeah, we came up with a classification for this event. So I'm sure you have suggestions and ideas how to classify things better. But let's have a first start. What we did there, you see there the various technologies in blue, the hard to abate. So we have iron and steel, we have shipping, we have the whole sector as a group, and we have chemicals, we have cement and aviation for now, right? And you see pretty consistently they generate lower returns, or we estimate that the returns are probably lower than in green overall, or in sort of other sort of emerging new fields such as AI. And you might say, well, that's a bit of a problem, and maybe it's not a good idea to invest too much in that, or recommend especially impact investors to focus on that. But again, there's a lot of variation, and you see there that in some countries it's higher than in others. So, for instance, India comes very high up. India, Brazil, Malaysia, Turkey are sort of the highest rank, and we can go down. And so we can zoom a little bit in, and you see that here, and basically the message here is, in India, yeah, their returns might be high in hard to abate, but there are other things in India that are even higher, right? And the same is true in Malaysia. Whereas in Turkey, we find that in Brazil more so in Turkey, that across a range of these sort of subsectors we identify there, actually the hard to abate technologies might generate the highest returns in terms of further R&D investment in those. And that seems kind of promising. And I'm curious to hear what you think about that. And I started to look a little bit into this, and we can back this up. This makes sense to some extent. So in a way, this is sort of an overall view across the whole of patented innovation at this point. But you can drill down on these and see. For instance, in Brazil, we have great aviation companies, Embraer, right, and companies like that. We have in Turkey, there are cement companies that are really at the forefront of innovating in green cement. So this it seems to be happening, and that might be an indicator and a new tool to sort of inform what is going on in different fields, not only in hard to abate. So let me summarize. We find that R&D in green innovation could be an area where we find that as a group, as a whole, developing countries seem to produce above average quality innovation, and so it could be a case for more investment in that area. Hard to abate is hard to innovate and hard to benefit from innovations, it seems, but there are exemptions. In some countries, you can identify pockets of high return, and maybe we should seize on that.
Thank you very much. Thank you. So I would like to remind everybody online to be thinking of questions and writing them down for us, please, if you have some, and I'll come to you. Well, I'll come to see if there are any in a bit. I have a few follow-up questions. I'm fascinated by this idea of R&D. I'm guessing that none of the businesses represented on the stage today see themselves as R&D businesses. Is that right? Would you describe yourselves as research and development? No. So you're consumers of technology that comes. So
consumers of technology.
I'd be interested, Ralf, we'll come back to you. Where is this R&D taking place? Like, what kind of business? But I wanted to ask you, Zahid, if I understood you correctly, you said that you thought 10 cents a unit would pay for what you would like. What would you spend it on? Like, what are the investments?
Yeah, investments
and then the kind of a associated bit of that is how much of what you think is important is in the actual garment manufacturing process, and actually how much of what's important from an environmental point of view is in the inputs that you use, so it's in your supply chain rather than in your factories.
Okay. So firstly, actually, it goes into certain technologies. For example, we have a target of reducing our carbon intensity to 25 and below. So for that, there are two major investments what is required. One is in terms of solar power, and the other is in terms of biomass boilers. So solar, we have done a calculation that it requires about, for us to do 30 megawatt of solar power plant, which is not possible in the rooftop. Rooftop, we have already done a 5 megawatt, but we need to go outside the premises, and that requires 30 megawatt to be done. And these two just investment 30 megawatt and this about 24 tons of biomass boiler, they itself will reduce our carbon intensity to below 25, which is currently somewhere around 42 or something like that. So this is the major direct intervention what we require to the investment. And of course, there are a lot of within the organization, the machineries and all, which requires some replacements of technologies. Like example, they are in terms of pumps, there are some IE standards of pumps which have come in. So we need to do those replacement all. But the major thing comes in terms of investing into the solar park, what we need. But again, the challenge remains is that, to make a 30 megawatt solar plant or 40 megawatt solar plant, that's a big chunk of land which we require, and it's never possible to get a clean land. So what we feel here that there's a good win-win case for everyone. Like for example, 5 or 6 companies, they come together, they want to invest into say 100 megawatt of solar power plant. The Bangladesh government, they have a target to go for 30% renewables by the year 2040. So maybe the Bangladesh government will come in by providing land. They provide land, we come with the finance, and we involve the international finance institutions like IFC, BII, and others, DEG and others and all. So yeah, this is going to help us. In terms of inputs, already we have invested into recycling. That is, the pre-consumer waste or the industrial waste, what we have, the cutouts, the fabrics and all. So that we have invested into a recycling plant. What we are doing that we are already making yarns out of it. So the cut clips which are there, we just do the mechanical recycling and make yarns out of it. So this has helped, we are doing on almost per day 5 tons of recycled yarn we are using. So this has a great impact in terms of, these are previously we were using virgin cotton. So those cotton is not required to import. So there's a good impact on the agriculture field, cotton field, where you're reducing water consumption, pesticides and other things also. So here these investments will go directly into, for example, we were talking about some research thing. For example, the battery BESS, battery energy storage system. So we feel that, it's not doable. But again, buyers are insisting upon us. So, if these funds come to us, then, we can afford to take the risk also. Because, technologies are continuously evolving. And even now, what is happening in terms of businesses, we have a very energy efficient machine. Now, businesses cannot go on to do their return on investment in terms of 10 years or something like that. 5 years, we have to just throw away our machineries and all, no matter how good the technology is, because there's a better technology which comes. So this requires a continuous investment into machineries and other things also. So the money what we get from the consumer itself is getting reinvested into the business, whether to reduce the GHG emissions or meet water climates, or again, go for more efficient technology.
So I'm inferring that if you need a bit of a green premium from the consumers or on the revenue side, then at least when it comes to solar in Bangladesh, you right now, that's not a cost saver.
It's a big cost saver for us.
Oh, it is
It's a very big cost saver for us because, we do not get the gas pressure. We neither get things. We are, in fact, using a lot of diesel, So it's going to reduce the emission. And it's more at this time as, the solar thing, the generation capacity is going up in terms of efficiency. The solar panels efficiency have gone down. The cost has gone down in terms of solar panels.
So that element wouldn't need extra money.
It's a very good return. Very good return.
Okay, thank you very much. Kinar, I'm worried I've misunderstood you. I think you were saying that matching the finance to the problem, the finance that you need is basically like a guaranteed product to give you a minimum price. So it's a bit like replicating an offtake agreement, but without there actually being an offtake agreement, you've got someone kind of making you a synthetic guaranteed price floor.
You can look at it in that way. I think it's this question about this price risk.
Yeah.
The creating demand, that is the private sector's job to do.
Yeah.
We have no issues with that, and you work with your network to be able to do it. The question is, how do you ride a price exposure that you have zero control over? And ultimately, in today's world, 2 people decide it, if we really are being brutal about it. It's drill, or go and do something that we don't like what's happening in the East, right? So if you want to attract private investment into these countries and you want to avoid emissions that are going to come, there's 2 sides of abating emissions. One is abating emissions that already exist, and the other is emissions that are going to come to deliver the demand that's coming. How do you do it? And green makes sense. I mean, you look at the charts over here, a different angle, but effectively green is the right answer because you can use local product. But you still have to compete with fossil. How do you do that? So I'm not saying, we want to sit back and have a guaranteed price. The finance institutions want that. they're the ones who say we want the guaranteed price to give you the debt. We'll take on the debt, but how are we supposed to guarantee that price? We have no control over it. So the question isn't create synthetic demand. The question isn't give us, a nice, easy ride. The question is, how do you find innovative solutions to deal with the fact that you're competing with fossil fuels if you want to get rid of fossil fuels?
Right. And Munish, I wanted to ask you about, we read all these wonderful things now about the Swedish using hydrogen to reduce the iron ore and the electric arc furnaces, but actually listening to you now, and I might be revealing my ignorance of the steel industry here, but if you're doing steel from scrap, none of that's really directly relevant to you at the moment, or is it? I mean, what I wanted to ask you is, when you read about all these wonderful new technologies emerging, are you there thinking, this looks terrifically interesting, we could be getting involved pretty soon, or are you still thinking, we're a long way away from wanting to go anywhere near that here in Nigeria?
Okay, so you were talking about the technology. So if you look at electric arc furnace technology, which you're talking about Swedish are doing, that is much more power intensive. So power consumption would be much higher. And I think most of the CO2 emission is coming from power generation. You talk about green steel, we are already moving towards that since we are setting up our own solar power plants. So the cost of solar is lower in comparison of the grid power. Grid power costs roughly around 15 cents, whereas per kilowatt hours, whereas the solar power cost almost 8 cents or 9 cents without battery. But once you add the battery to it, then cost go high. So we started to produce steel from solar power during the day in few of our plants. And idea is to just go and implement it. The technology is evolving, as Zahid said, that cost is coming down. So as the cost come down, probably battery solution would be there, and then we would be producing steel from solar power.
Okay, so
green steel.
Reasonably close to being commercially worthwhile, and you will adopt it as soon as the kind of cost.
Yes, we already started halfway, so we have already moved halfway, and remaining half we will cover once the battery costs come down. Thank you.
Great, thanks. Maybe Mamuna, I was going to ask whether they had any online questions, but you've slipped out. What else did I have on my questions list? Stephanie, it was what I wanted to ask you more about is this sort of a complementary infrastructure point, because everyone focuses on like the electrolyzers and the costs of like the kind of the production of the molecules themselves. But where are you are you seeing some of the countries on your map where you were identifying like this is probably the best place to be producing? Is that because you're already seeing investments in the complementary infrastructure in those countries, or is it kind of hypothetical still that if it was there, this would be the best place to do it?
So no, this is this is purely just the cost of production of green hydrogen, the least cost, and this is come after this sort of push to export from the continent, right, into Europe. However, I would say one of the core aspects that we're looking at, and I think it's actually quite interesting what you've been saying, and obviously here, is sort of this role of, so we're currently modeling the need of fertilizers into 2050 and modeling the need for green hydrogen to produce ammonia-based fertilizers, right? And then also I think so we're doing this for certain countries. So we've done Kenya, we're doing Nigeria at the moment. So we're then deep diving into some sort of like sectors in the country and integrating where would it make sense for those countries. Look, I think there always has to be a component of export simply because of the de-risking and the capital flows and all sorts of things. But like where can a country produce its own value and what role does that have to play on the continent? But I just want to very quickly reflect on this idea of the green steel, right? I think it goes back to this optimization question, and I must sound like a modeler. I'm not a modeler. I take my team's models and then I make sense of this. But I think it's this optimization, right? I think, for example, what you're saying, what makes sense for you, right, is to use the daytime solar to produce green steel and then substitute it. And I think it's this where we're getting it a little bit wrong. We're trying immediately to completely change the system, when actually maybe there needs to be a bit more of an incremental change. And that is a really good way of doing it, because we know that batteries are expensive, and obviously renewable energy currently does contribute the highest amount of green hydrogen production. So we're also looking at salt cavern in the case of Ukraine, for example. So we're exploring different options of how can we actually push down, reduce the price through better flexibility and optimization. But how can we more so importantly create value for the countries where those sites are being located? So it's not very extractivistic. It's also value creating. So, even though maybe I came across quite strong and gave you a good lead into your part, but I think it's fascinating and really important that this is happening.
Thanks. Let's see if we can get some questions out of the audience. Can we get the microphone travelling around, please? Anybody got any questions for our panelists? No. Right, okay. And Mamoon is not here to tell us if there's any questions online. So I was then going to ask, I'm worried about this is too much of a dangerous question, Kinar, but how big is the gap between what you can make fertilizer for and what the Ugandan market price is for fossil imported fertilizer at the moment?
Who's got the perfect crystal ball? Is my answer to you. I mean, and that's really what I'm trying to get at here, right? If you look at Uganda's current industrial tariff, it's at about 5 cents per kilowatt hour. Back in 2022, no problem, you'd be a billionaire overnight. Back in 2023, very good, you're making very good returns. Early 2024, the project is great. Today, gas prices are at 25 euros a megawatt hour on a forward basis. Doesn't quite work. So at what point in time? And that is a challenge that we face. Prices move week to week, day to day. You don't have, you want to go and build a windmill out, if you go back 10 years ago, you wanted to build a windmill, governments would underwrite that power price. They would take the risk, and I'm talking about in OECDs, not just in Africa. They would give you a fixed price PPA, even though market prices are fluctuating. And they would give you the guarantee as an investor that you can recoup your money. And that allowed the market to evolve to a stage where today you have much better liquidity, much better hedging mechanisms to manage that yourself as a developer. Still, you look at offshore wind, they still need some form of stability in pricing. And that's what we're saying is if you want to make these green industries work, if we're really serious about it and we're taking CO2 as a global problem, not as a UK, Germany, Netherlands, Norway problem, but a real global problem where 1 ton of CO2 reduced across the world is a benefit, then let's try and find those same mechanisms that you're using on one side to make green work.
So taking the point about, it depends what year you're asking about, at least things have got close enough that there are some years where you are cost competitive with fossil.
Yeah, sure. If we had taken FID last summer, at that point in time, it would have looked perfectly fine. Right. Your project is great. Today, you take FID.
Okay, I wasn't aware that the prices were already.
You're not looking at a big difference. And the insurance that you're talking about, the cost of this. The cost of a CFD is actually quite low when you break down. You can go and mitigate that through market mechanisms. It doesn't cost you very much, and it is an insurance product.
Okay. So you're selling to a domestic market. You're also selling to a domestic market. So one of the kind of big themes in this area is the Europeans and their carbon border. The taxes that they're going to be imposing on imports based on carbon intensity. At the moment, that's not a concern for you. Is that applying to your business, though? Very much
it's
so?
A big concern.
Yeah.
We cannot go to export, if we do not do this intervention in terms of reducing.
Yeah.
Because, our brands and buyers, they are going to buy from organizations which has got lower carbon intensity. So if we are not living up to that expression, then, we will not be into the business. And so it's mandatory for us to go for these implementation changes.
And do you think that these taxes are going to change the geography of where garments are made? Or do you think that the kind of incumbents are going to
So, this actually, what's happening, the buyers, especially after COVID, they have been changing their sourcing strategy. For the first thing, what they did was that, after COVID is that they have narrowed down on the supply. They are looking for organizations which are more financially sound. So they have reduced the supply chain limits. Now what they are doing is that they are having strategic supply. So for example, where a buyer was having, say 100 suppliers, now they're just working with 25, 30 or something like that. So with these, they are very closely working and developing them in terms so that, they're able to continue the supply chain and sourcing and all. So what's going to happen is that, a lot of companies are going to shut down. And again, the ones who are doing good, they are going to grow further. So this will be the change which is going to happen. It's not that it's going to move from country to country. That's not going to change because Vietnam is developing, Bangladesh is also developing. Yes, for Bangladesh, there's an advantage because Chinese investors are coming to Bangladesh. So we are in a sound position, in terms of future businesses and all.
Great. And Ralf, I'm not sure. I might ask you an unfair question because you are a researcher within the IFC and not on the investment side. But from what you pick up on, what your colleagues are doing on the investment side, where are the places where they're finding their first steps into these innovative green businesses in the global south? And I'm guessing maybe Turkey for cement and places like that. Are you seeing transactions starting to appear where part of the money is is going to trial and scale up new methods?
Well, I mean, I don't have a full view of the whole portfolio, but I mean, it's a key area. But I mean, maybe the curious thing they invested actually in, and that might be interesting for you. They invested in Boston Metals, and I think it's kind of unique. I think it's one of the first IFC investments, not in a developing country firm. But I think the rationale is that they believe they have a key technology and they want to sort of help to develop this technology that can then easily be transferred and scaled in developing countries. And that would be and I think it's one of the few, I mean, like you, I don't have a clear idea about the process, but it's a technology that really makes steel making carbon free entirely. And so I think I mean, what it shows is there are some kind of unusual steps being taken in that field.
That's a very interesting thing. I'm curious whether that was an awfully difficult thing to persuade the board of the IFC to do, or whether they saw the logic. And
I'm very happy to put you in touch.
So we still have 15 minutes left. I'm going to make one more appeal to the audience. There we go. Thank you very much, Chris.
Thank you, Patty. Two questions. One on Boston Metal. I just read something about that. There is a component of that investment which is in Brazil. So that one of the things Boston Metal is doing is a demonstration plant in Brazil, and that's the part of the IFC investment that makes more sense for IFC in terms of traditionally what they've done. But there was a prior investment into that. I think that's something that they think of as
investment in the whole thing, right?
It is. Yeah. No, it is an interesting angle in what they're doing. Zahid, I had a question for you, and which is, can you unpack a bit more the circular economy kind of part of greening garments, and in particular, what types of investments or examples of investments that you would need to make to sort of increase the share of recycling of fabrics, and what the sort of either support or pressure from buyers is to undertake those investments, and kind of how we think about those.
Okay, thank you. So actually, what has happened, DBL has taken this particular initiative about 4 or 5 years back itself, and without any pressure from the brands or buyers, we went for, because we have a spinning mill. From that value addition, all the processes are there. So what we are doing is, from the spinning mill waste, we are utilizing it. Then we are also utilizing the garments waste, which is the cut clips which comes from the sewing lines, and also the fabrics which get rejected in terms of process. So all of these fabrics we are able to make, again, through mechanical recycling, we are able to make the yarns. So we have a capacity to do 16 tons of processing for this particular thing. And this is for 100% cotton. So the cotton recycling in the circular economy is very simpler compared to the ones which has got mixed fabrics. For example, you have spandex within the things and all. So those are the ones which require very heavy intensive investment. It's called as the chemical recycling, So through which, you are able to separate those particular things and all. So in Bangladesh, mechanical recycling is going up, but chemical recycling is still on hold. It's not going at the fastest speed because of the heavy investment which is required. Here, there's a project by UNIDO, which is switch to circular economy. So because, the European Unions, a lot of countries, they're having this recycling thing coming in that, they want circular economy, then they want to have the EPR, extended producer responsibility. And all. So this they are promoting together with two brands. One is H&M and the other is this one, Bestseller. So they are promoting this particular thing. So in terms of cotton recycling, this is going up. But in terms of chemical recycling, where there's an intensive investment, that is not moving fast, And again, like when you're recycling the yarn, but you cannot make 100% out of it. I mean, you need to mix a percentage. Say 70% is virgin cotton and 30% is the recycled yarn through which you're making and then you're utilizing it. Only Puma has been able to do where you can make 100%, you use 100% recycled yarn and make a product. That's the innovation, what they have been able to do for a particular thing. But in terms of investment, I don't know exactly what would be the amount or something, but chemical recycling is very much required. And there are some organizations who are working on terms of research, what technology can come in. But that's the biggest investment what will be required.
And our most discarded clothes, I presume they're mixed. I mean, the bulk of the material is mixed.
It's mixed, You have, again, you have metals, you have buttons and others. So how those can be discarded?
We have a question online, I think.
It's a question from Henry Harris. How important is local currency financing in bridging the gap for hard-to-abate sectors versus simply USD financing?
Who would like to take that?
I will take it, yes.
Yeah.
No, it is extremely, extremely important. And that is the one issue which comes since Nigeria, in last 3 years, we have seen devaluation almost 300%. And one of the constraints we are facing when we go for DFI financing is whether we want to take dollar exposure or not. So there was quite a bit of reluctance in last 3-4 years since currency was devaluing. But now currency is getting stable, so people are still optimistic about dollar financing. So if you are selling in the domestic market, your realization is in local currency. And if you take dollar exposure, that might be very dangerous for you, and I have seen quite a few businesses going down due to that. So it is very important, and I don't only local DFIs are doing, and somebody like InfraCredit, I met somebody from InfraCredit, they are doing it. So it is extremely important to do that, and there is a way to do it also, where you can go to central bank and then central bank do swaps, and there are ways to do it. Some of the financial institutions are doing it, but most of them are still reluctant and they want to do only dollar or euro financing. Thank you.
Kinar, are you having conversations about the currency of the financing in the Uganda project?
No, thankfully the off-takers that we're discussing with, they're happy to take that risk. So we are hard currency not fitting.
Okay, great. That's it. Well, look, why don't we wrap up then? So thank you very much to all our panelists. It's been fascinating. Thank you very much.
Thank you.